This is Rev. Michelle Hopkins. On November 25th, 2010, satellite LASCO C3 took some very interesting imagery at 12:18:05 a.m. The first thing that LASCO caught seemed to be a through-and-through flare. At one end of this solar flare, there seems to be something that appears to be a rocket propulsion trail, or perhaps multiple laser emissions. At 12:30:05, another rocket propellant trail from engaged satellite thrusters seems to be leaving this end of the solar flare, going toward this next through-and-through solar flare moments later, less than half an hour later. But was this really a through-and-through flare? Or did something travel through the sun's corona and possibly even through the sun, perhaps not through the core? Upon a closer look at this emission, if you will, we find that it seems to be going in this direction. There seems to be 2 beams going through the sun, and they seem to be congealing, perhaps crossing, and going back through the other side. I believe these are laser beams from a heliocentric satellite. A laser satellite that is orbiting the sun at 1:30:22 a.m. that same day. A laser satellite is seen deploying not 1, not 2, but 3 laser emissions. This is a laser demonstration. This is a 4 beam. This comes forward and at this point goes through particles that are space matter. So it becomes dimmed and then it becomes brighter as the particles are less dense. It shows also that this aft space laser beam coming from this satellite, it is a solar satellite, a heliocentric satellite. The aft beam is going through the through-and-through solar flares that were created through these laser beams, apparently. What it's demonstrating is not only can it go through all of this laser flare, this radioactive material that's being belched out furiously from the sun, from these 2 wounds that were just placed in it. Not only doesn't disintegrate the beam, but it allows the beam to continue on its way to its intended target. The beam is barely affected. At the same time, the beam is allowed to go backwards. All 3 beams simultaneously. The 3rd beam is also accurate enough to go through another subject. This is an amazing solar laser satellite demonstration picked up by LASCO C3. This demonstrates what I've been telling you about what's going on regarding our solar politics. There are 4 countries that I'm aware of that have solar satellites that are orbiting the sun that are also equipped with lasers and other spectrographic instrumentation. Japan, China, Russia, America. At 2:45:05 a.m., the convective zone of the sun has come back together underneath the corona, ejected the flares, and has healed itself, thankfully, beneath the corona. And this through and through flare is all but healed, and these through and through flares are on their way to being healed. Many are wondering if all of this is real, if we actually have solar satellites. Well, they're called heliophysics satellites, and they are solar satellites. Many of them orbit the sun. Some of our current solar satellite missions include ACE, ACE, or the Advanced Composition Explorer. This spacecraft carries 6 high-resolution sensors and 3 monitoring instruments that sample low-energy particles of solar origin and high-energy galactic particles with collecting power of 10 to the 10,000 times greater than the past. This satellite works from a vantage point of 1/100th of the distance from the Earth to the Sun. In other words, 1% of the distance from the Earth to the Sun is where ACE satellite orbits around the Sun. Part of ACE's prime objective is the solar corona, the solar wind, and other interplanetary particle populations. Then there's RESI. RESI is a high-energy solar spectroscope imager. It is a laser telescope. It has 3 objectives: impulsive energy release, particle acceleration, and particle and energy transport. Then there is the Hinode Solar B. Now in operation, it was deployed in 2006. The Hinode Solar Optical Telescope is the first space-borne instrument to measure the strength and direction of the Sun's magnetic field in the Sun's low atmosphere, also called the photosphere. This image from the Solar Optical Telescope shows a greatly magnified portion of the solar surface. This is a mirror that might be used on an X-ray telescope, laser telescope, infrared telescope, or gamma-ray telescopes that are often found on satellites. The issue of how far a laser beam will travel in outer space has been brought up to me. And here we see a depiction of space laser beams crossing 5 million kilometers of space in a great deal of magnetic turbulence. Now let me introduce you to NIF, N-I-F, the most powerful laser in the world. Here is the inside during the construction of NIF. It was built by scientists working at the National Ignition Facility of the Lawrence Livermore National Laboratory in California. It's capable of simulating the energy force of a hydrogen bomb and the sun itself. This is Rev. Michelle Hopkins. Thank you for watching, and God bless you.